Okay, so this is our probability project by Mackenzie and Savannah.
Okay, so this is our game board. This is our game board. You have 3 balls on the left side of the game board, and then you have 10 holes. Ideally, if you were doing this in person, this would be a wall with 10 holes in it. Then underneath each hole is a picture of a different kind of puppy with the name of the puppy and the average cost of the puppy. Out of the holes, there are 10 leashes of all different lengths.
Of the game, there is a wall with 10 holes in it. Each hole has a picture of a different dog underneath the hole. Each hole has a dog leash hanging out of the hole, and they all look the same length. However, the leashes are not the same length. It's kind of like drawing the short straw. There will be 2 long leashes and 8 short leashes. The person playing the game has 3 chances to throw the ball into any hole they choose. If they get the ball into a hole, the person running the game checks the length of the leash. If the leash is one of the longer ones, then the person wins that type of dog that is underneath the hole. If they do not put the ball, if they don't throw the ball into the hole and pull out a long leash, then they don't win anything. After each person that plays, the leashes get switched around so that the next person doesn't know where the long leashes are. Okay, so the instructions of the game are pretty simple. So, first, you have 3 balls to throw into a hole of your choosing. Second, if you get the ball into the hole, the person hosting the game will check the leash hanging from the hole to see what the length of it is. Third, there's a short leash and long leash hanging from the holes. If the leash is one of the few long leashes, you win the puppy that is pictured underneath the hole that you threw the ball into. And if you don't have a long leash, then you don't win anything. And if you don't get a ball into the hole, you also don't win anything. So you want to get the ball in the hole, and you want to try to, I guess, figure out which one has the long leash. So you actually do win the puppy. So some details of this slide would be, or some details of the game would be that it costs $50 to play. The mathematical goal is like this is like a probability game. And the possible prizes you could win would be a German Shepherd, Bulldog, Labrador Retriever, Golden Retriever, Husky, Poodle, Dachshund, Great Dane, Rottweiler, and Corgi. And all these would be puppies. And what you'll need is 3 balls, 10 leashes to play this game. So this is the, I guess, all the possible outcomes. So up here you have all of the different dog breeds listed, and then you have them. They can either be a long leash or short leash, just depending on how the host of the game lays it out. And then here it is, our sample size with all of these listed out right here.
So the probability of all outcomes. The probability of pulling a long leash is 2 out of 10 since there's 10 holes and there will be 2 long leashes, or 1 out of 5. The probability of getting a short leash is 8 out of 10 or 4 out of 5 since there's, again, 10 holes and 8 short leashes. Since the leashes get moved around each time a different customer comes up to play the game, there isn't a way to find the probabilities of getting each dog. There's only a way to get the probability of the long leash and the short leash. So to explain further, since all of the leashes will be moved around so the next customer doesn't memorize where the long leashes are, then there's not a way to figure out the probability of each dog. So that's why we did the probability of long leashes and short leashes. Odds of winning a prize for all values. Odds in favor are 2 out of 10. Odds against are 8 out of 10. And the math is 2 out of 10 divided by 8 out of 10 equals 2 out of 10 times 10 out of 8 equals 2 out of 8, which simplifies to 1 out of 4. So the odds of winning is 1 to 4. Expected value of winning the game. This one's a little bit complicated because, again, you can't really find the probability of each dog. So we had to do an example of just one person playing the game and not like everybody at the carnival playing the game. So since there's 10 holes a game in the game, there's 10 items in the sample space. So each of them have a random long leash or short leash. And we chose for our sample space long German Shepherd, long Dachshund, short German Shepherd, short Labrador Retriever, short German Shepherd, no, short Golden Retriever, my bad, short Husky, short Pit, P, what is P? Sorry. Short Poodle, my bad, sorry about that. Short Golden, short Great Dane, my goodness. Short Rottweiler, and short Corgi. So the probability of getting a long German Shepherd is $1,000 because a German Shepherd costs $1,000. And then the probability of getting a long Dachshund is 450 because a Dachshund costs 450 on average. And then the probability of getting any of these short leashes is 0 because you wouldn't win anything. So when you figure out the probability of each, it's 1 out of 10, 1 out of 10, 8 out of 10. Then when you multiply each probability by how much they cost, you get 100 plus 45 plus 0 equals 145. And since the game costs $50 to play, the game is not fair because you could get a lot more money in a dog than you would from just giving $50 to the game. To make the game fair, we could change it so the customer would win a stuffed animal of the type of dog pictured underneath each hole rather than an actual puppy. But imagine going to a carnival game and instead of getting a fish, you get a puppy. That's just insane. And so we wanted to make it fun like that, so we did. And yeah, that's it.